Good morning students. This session we are going to see about disk drive components and disk drive performance. What are the various types of disk drive components are there? First we'll have a brief about that. The key components of a hard disk drive are plater, spindle, read-write head, actuator arm assembly and control board. These are the components which are being shown in this diagram. So here HDA, one of the component is there, that is called it as head disk assembly, and it was supported by the controller board, and there is a interface card for connecting the devices. And here the I/O operations in hard disk drive are performed rapidly by moving the arm across the rotating flat platters coated with the magnetic particles. So, how the data will be transferred in between the disk controller and magnetic platters? We have to move the read-write head which is attached to the actuator arm. So, we can able to record the data as well as we can erase the data which doesn't want, which is already stored in the magnetic platters. For any number of times, if you want to do the operation, it is possible in the disk drive components. And this is what the physical disk structure. Here you could able to see the sector, track and plater information. So here one more component has to be placed, that is called it as a spindle, which could able to connect the more number of tracks at the same time. It can be act as a central central point, or we can say the central component which can able to connect the number of platters. The spindle. So the spindle connects all the platters and is connected to the motor. And whenever the motor of the spindle rotates with a constant speed, then the disk starts to rotate. And what about the plater? In the sense, it is one of the important component in your hard disk drive, which consists of one or more flat circular disks. You can see in this diagram, it can be called it as a plater. So each plater will consist of the set of tracks and the sectors. And here HDA, which we already seen in the previous diagram, the set of rotating platters which could be sealed in a case, that can be called it as a head disk assembly. And we'll see the disk drive performance. And before to move on to the disk drive performance, we'll see the options of the read-write head and the actuator arm. Actually, these read-write heads are mounted on the actuator or arm assembly, which position your read-write head at the location on the platter where the data needs to be write and from where you are going to read the data. So here the read-write heads of all the platters on a drive are attached to one actuator arm assembly, and that can be moved across the platters simultaneously. And the disk drive performance. So in your electromagnetical mechanical device, it impacts the overall performance of the storage system. So here disk service time we have to calculate, that is the time taken by a disk to complete an I/O request depends on the seek time, rotational latency and then data transfer rate. So how to calculate the disk service time? That means by adding all the three, that is the combination of seek time, rotational latency and the data transfer time. So by adding all the three, then we'll get the disk service time. Now seek time. What is the seek time? The time taken to position your read-write head. How long it takes to position your read head or write head. That is nothing but the seek time. The lower the seek time, the faster the I/O operations. When seek time is more means you are taking more time for positioning your read-write head itself. So always the I/O operation speed will be decreased. So seek time specification will includes three categories, that is full stroke, average and track to track. We'll see one by one now. Full stroke. The time taken by the read-write head to move across the entire width of the disk, that is nothing but full stroke. At a stretch, if you want to move the complete rotation from the innermost track to the outermost track. And average is nothing but the average time taken by the read-write head to move from one random track to another track. Normally, it could be listed as the time for 1/3 of the full stroke comparatively. And if you take the track to track, in the sense, the time calculation for read-write head to move in between the adjacent tracks. How long it takes to move the read head or write head to move between the adjacent tracks. That is one track to another track. That is what the track to track time. So these are the important seek time specifications. So the seek time of a disk is specified by the drive manufacturer. Then rotational latency. Here the time taken by the plater to rotate as well as the position the data under the read-write head. And it depends on the rotation speed of the spindle. How fast the spindle can able to rotate. Based on this, the speed will be vary. And average rotational latency is nothing but 1/2 of the time taken for the full rotation. Now the next factor is data transfer rate. That is the average amount of data per unit time that the drive can deliver to the HBA. So what is this HBA? HBA is nothing but the host base adapter. So mainly whenever you want to connect your host to any of the device, okay, so we need the help of this HBA, that is host based adapter. And the data transfer rate mainly in any of the read operation, if you take the data first move from disk plater to read-write head, then it is moved to the driver's internal buffer. Finally the data move from the buffer through the interface to the host HBA, that is nothing but the host base adapter. So this is what the general sequence flow for calculating your data transfer rate. Here we can have two types of transfer rate. One is internal transfer rate, another one is external transfer rate. You can see this diagram, the internal transfer rate, how they are calculating the internal transfer rate. It is the speed at which the data moves from a plater surface to the internal buffer. That is nothing but your cache of the disk. And the internal transfer rate takes into account such as the seek time as well as the rotational latency. But the external transfer rate, how we are calculating the external transfer rate, in the sense, in between your disk and the host base adapter connection, we need to calculate the data transfer rate. That is, it's the rate at which the data can move through the interface to the HBA. The external transfer rate is generally the advised speed of the interface, such as 133 MB per second for any of the advanced technology attachment. And this is the diagram for host access to storage. So here you can have the direct attached storage. That means by using block level request, any of the applications, it can be communicated to the storage directly through the file system. In the storage networking options, we have block level as well as file level access. So in compute part, the application and file system can be connected to the storage via the storage network, and here it is file level access. So in compute side you have an application, so the application can be connected to the storage system via storage network for file level request. So the file system is available in the storage system for. So on file level, if you want to access any information, then you can prefer the second part of the storage networking options. Thank you.